Welcome all. In this lecture, we will discuss about Fourier transform. So, Fourier transform of a signal x of t is represented as x of j omega and is defined as x of j omega is equal to integral over the limits minus infinity to infinity x of t e raised to minus j omega t dt. So, we are finding the Fourier transform of this x of t. So x of t, we know that the x of t is a signal where the signal is a function of time t. So it is a time function, and actually Fourier transform is a function of frequency. So this will be a function with respect to frequency. So it is a frequency function. So by doing Fourier transform, we are converting the time domain function into a frequency domain function or signal. So we can find the x of j omega, the frequency domains or frequency function from the time function by doing Fourier transform, and we are representing this as x of j omega is the Fourier transform of x of t, f of x of t. And we can find the x of t from x of j omega also, the reverse. Means we are finding x of t from x of j omega by doing inverse Fourier transform. And we are representing it as f inverse of x of j omega will be equal to x of t. And the equation is, we can find the x of t from x of j omega by x of t equal to 1 by 2 pi integral minus infinity to infinity x of j omega e raised to j omega t dt. So this is actually Fourier transform, means we are finding x of j omega from x of t. And this is inverse Fourier transform, means we are finding x of t from x of j omega. And there are some conditions for the existence of Fourier transform. The following are the conditions to be satisfied for the existence of Fourier transform of signal x of t. First one is x of t should be absolutely integrable, means integral over the limits minus infinity to infinity magnitude of x of t dt should be a finite value, means should be less than infinity. It cannot be infinity. And second condition is x of t should have finite number of maxima and minima within a finite interval. And third one is x of t should have finite number of discontinuities within any finite interval. These are the conditions to be satisfied for the existence of Fourier transform, and these are also called as Dirichlet's conditions. And next one is the relation between Fourier transform and Laplace transform. So we know that the Fourier transform is actually the conversion. We are converting the time domain signal into a frequency domain signal. And Laplace transform is also a transform which convert the time domain into S domain. So we know that the Laplace transform of x of t can be found as x of s. X of s, the Laplace transform of x of t by the equation x of s is equal to integral over the limits minus infinity to infinity x of t e raised to minus st dt. Substitute s equal to sigma plus j omega. We know that s is a plane having real part and imaginary part. So s is sigma is the real part and omega is the imaginary part. So we can say that it will become, when we are substituting s as sigma plus j omega, x of s is equal to e raised to minus infinity to infinity, x of t e raised to minus s become sigma plus j omega. And we can split this. We can write it as e raised to minus sigma t into e raised to j omega t. E raised to minus sigma t into e raised to minus j omega t dt. So if you are considering the Fourier transform equation, x of j omega, the Fourier transform of x of t is minus infinity, integral minus infinity x of t e raised to minus j omega t dt. So if you are comparing these two, this is actually the Fourier transform of x of t. So this is, instead of x of t, here it is x of t into e raised to minus sigma t. Means this is actually the Fourier transform of this function x of t into e raised to minus sigma t. So we can say that the Laplace transform of x of t is the Fourier transform of the function x of t into e raised to minus sigma t. So that is the relation between Fourier transform and Laplace transform. And suppose here sigma is 0, means s is having only imaginary part. This equation become, this e raised to sigma t become 1. This sigma is 0. So it become x of s is equal to integral minus infinity to infinity x of t e raised to minus j omega t dt. Means these both are equal. Means Laplace transform is equal to Fourier transform. So we can conclude that the Fourier transform will be equal to Laplace transform when s is equal to j omega. Or we can say that if s is equal to j omega, we can find the Fourier transform from Laplace transform by simply substituting s equal to j omega. So with this we can wind up the session. Thank you.